India's Chandrayaan-3 spacecraft speeds toward the moon ahead of historic landing attempt, capturing stunning images along the way. The Indian Space Research Organisation, ISRO, confirmed on August 22 that the Chandrayaan-3 spacecraft is right on schedule and operating smoothly, sailing smoothly on its mission. The landing module, Vikram, of the Chandrayaan-3 mission, is expected to commence its descent to the lunar surface at 1745 IST on August 23, or 1915 Vietnam time. If successful, this mission will mark India's first soft landing on the lunar surface and elevate the nation to join an elite group of 4 countries in achieving such a remarkable feat. Currently, only the United States, China, and the former Soviet Union have successfully conducted controlled spacecraft landings on the moon. India's space agency will broadcast Chandrayaan-3's landing attempt live starting at 1720 IST on August 23. On August 21, the Indian Space Research Organisation marked the eve of the Chandrayaan-3 landing event by sharing images and footage captured by the spacecraft's onboard camera. A clear image of the moon's surface from an altitude of 70 kilometers reveals features such as Mare Marginis, a large dark spot formed by ancient asteroid impacts along the lunar near side. The near side of the moon always faces Earth, in contrast to the far side. Only one side of the moon is visible from Earth because it rotates on its axis at the same rate it orbits the Earth. Another image, captured on August 20 from a much closer vantage point as the spacecraft passed by, provides a close-up view of the moon's rugged, dust-covered terrain. According to the Indian Space Agency, Chandrayaan-3 spacecraft can orient itself by matching images taken by its onboard camera with a programmed map of the moon. According to the Indian Space Agency, Chandrayaan-3 spacecraft can orient itself by matching images taken by its onboard camera with a programmed map of the moon stored in the spacecraft's computer. Chandrayaan, which means mooncraft in Sanskrit, was launched from the Satish Dhawan Space Center in Sriharikota, southern India, on July 14. The spacecraft has been approaching the moon's surface slowly. The Chandrayaan-3 mission marks India's second attempt to achieve a controlled landing on the moon. The first attempt, with Chandrayaan-2 in 2019, saw the lander crash on the lunar surface due to a software glitch and difficulties with braking during descent. The lander, Vikram, on the Chandrayaan-3 spacecraft carries a small rover called Pragyan. Powered by solar energy, this duo will explore the lunar surface for 1 lunar day, approximately 14 Earth days. Before the lunar night descends, lasting an equal 14 Earth days, causing them to run out of power, Vikram approached the moon's vicinity on August 20, after completing its final deboosting maneuver to fine-tune its orbital position. This maneuver brought the lander to an orbit with its closest point to the moon being 25 kilometers and the farthest point at 134 kilometers. ISRO mentioned that it will undergo self-checks and await the designated landing site as they wait for the sunrise at that location. The landing site for this lander is the lunar South Pole, where there's a high likelihood of valuable water ice resources for propulsion or sustaining life. Vikram carries 4 scientific instruments, including a thermal probe capable of penetrating about 10 centimeters into the lunar soil and recording the temperature of the lunar regolith throughout the lunar day. Vikram is also equipped with a retroreflector, expected to remain functional long after the lander itself ceases operation. Meanwhile, the Pragyan rover is equipped with a laser-induced breakdown spectroscopy (LIBS) instrument and an alpha particle X-ray spectrometer (APXS) for studying the lunar soil and rocks. Just days before Chandrayaan-3's scheduled landing, Russia's Luna 25 mission experienced an incident that caused the lander to crash onto the lunar surface. On August 21, the head of Russia's space agency, Roscosmos, Yuri Borisov, revealed the primary reason for the failure of the Luna 25 mission. It was due to the spacecraft not shutting down its engine in time and deviating from its intended orbit. Unfortunately, the engine did not shut down normally, according to the sequence diagram, but based on the timestamp, and instead of 84 seconds as planned, it occurred in 127 seconds, Borisov told Rossiya 24 television. This factor was the crucial cause behind the mission's failure, Borisov declared, adding that a special commission has been formed to investigate the incident.